Welcome back. In this video, we're going to continue learning about matter and measurement by using dimensional analysis to solve problems and relate density, mass, and volume. Let's start by defining density. Density is an example of a physical property of matter. It's defined as the mass of a substance per volume of that substance. Substances of a given volume that have more mass are more dense. Or you might have a set mass, and you can change the volume, and that would make the substance more or less dense. We'll see different examples of these throughout the semester. All right, let's jump right in and start looking at some problems here. The most dense element, osmium, has a density of 22.59 grams per milliliter at room temperature. For comparison, iron has a density of only 7.874 grams per milliliter. What is the difference in mass between a 250 milliliter block of osmium and a 250 milliliter block of iron? Let me walk you through this problem. So we can use the notion of density in order to find the masses. We can find the mass of osmium by taking the volume that we're provided and by multiplying by its density. When we do that, the units of milliliters will cancel out, and we will get 5,647.5 grams. Now, when you're doing this calculation, we should note that we are only going to have two significant figures. The reason for that is because of our volume is expressed only to two significant figures. To find the mass of the iron, we can take the volume and multiply by the density. When we do that, the units of milliliters will cancel out, and we find that the mass is 1,968.5 grams, again, rounded to two significant figures. So if we want to find the difference in mass, we need to subtract the mass of iron from the mass of osmium. When we do that, we get a value of 3,679 grams. When we take that and we round to two significant figures, we get 3,700 grams. So let's talk about this. Let's evaluate what we did and why. Well, as I expressed earlier, the equation for density is expressed as mass per volume. So if we want to find the mass of an object, then we can take and multiply both sides of this equation by the volume. So if you take the density, multiply by the volume, you get the mass. Another thing to consider is thinking about this in terms of the units. When we solve problems, a lot of times you can figure out what path you need to take just by looking at the units of your final answer, the units of what you have to start with, and thinking about the relationship between them. So we knew that we wanted to find a mass, and we were given a volume. And the relationship between mass and volume is density. So it makes sense that we would use the concept of density to combine, to convert from the mass of one substance into the volume of that substance into the mass of that substance. Okay? All right, let's try another problem. A certain fuel releases 56 kilojoules of heat per 100 grams of fuel burned. How much fuel would you need to burn in order to release 0.25 joules of heat? I'd like for you to pause the video and try to solve this one on your own. Come back, and then I will provide you a solution. Welcome back. So this one doesn't involve density, but it does involve a similar approach to what we saw before. What we see here is that we have a certain desired amount of heat that we want to produce, and we want to know how much mass is required in order to make that possible. So we can use dimensional analysis to solve this. In the end, we want our answer to have unit, or we have really heat. And we want to find units of mass. And we see here that there is a relationship between mass and heat. And so if we can use that relationship between the mass and the heat, our units of heat will cancel, and we're left simply with units of mass. So let's try that. Let's write this first as a ratio, 56 kilojoules per 100 grams. We then will convert our heat from joules into kilojoules. 1 kilojoule is 1,000 joules because of the prefix kilo. We can express that as a ratio as well. So if we have 0.25 joules, we'll convert that from joules to kilojoules using this ratio. The joules cancel, and we're left with kilojoules. We can then multiply this by the ratio. Now, if we multiply by this ratio, 56 kilojoules per gram, as is, our final answer would be would be some number to kilojoules squared per gram. And that's not what we want. So we need to multiply by the inverse of that ratio. Be very careful as you're solving these problems, so that way you use the ratio in the proper direction. And the way that you can tell is by evaluating what units would you get when you multiply. So, pro tip, always write out your units. Always, always, always. When we do this, our units of kilojoules cancel, and we're left with grams. When we round to two significant figures, we get 4.5 times 10 to the minus 4 grams. That's an answer choice of B. So that's it for this video. Thanks for watching. Have a great day.